Today we will discuss HMI, Kinco HMI communication, how we can do communication and how we can read, write by communications. So first we will take a new project just only for the test. So I will explain you how I can do this. This is my HMI type is G121E. Just only we go to next. And this system parameter set is opening. Okay, just you can see here we don't have anything small. Also you can go to options and system setting. Note this one, system parameter and system setting. Again is opening that first thing. Sorry, now don't know why it's stopping. Okay, no problem. New project and test. Not this next exercise. Okay, yes, no problem. I will cancel and I go again to system parameters. Yes, this one is opening here. So my HMI have one Ethernet port, one COM port 0, 1 and 2. Actually this is 2 ports, so there is option you can use 232 and 485 together in one COM port. Okay, this is important here. Just remember we go, and now I will go explain you how many communications here I have. Okay, now you can see here the first device COM1 I communicate with Mitsubishi FX3U. So first we go to this one. I will go to system parameter and settings. COM1 FX3U. I will use RS422 communication, and baud rate is 9600. This is 7 event 1. So this is so if you want to communicate Kinco HMI with FX3U Mitsubishi PLC, this is the base of the communication. So you can do like this if you learn about the Kinco HMI and FX3U communication in manual SO writing. So first, if you want to communicate, you can communicate with these parameters. So directly communicated, no need anything small. Just you need to go here. Also here I can go and COM1, and I will add here. So I will delete. First you need to choose and delete. Here I need to go Mitsubishi and FX3U. This is if you have so for 85, so DB and BD, so you need to choose here. I just only go with here FX3U, and I will do add. Just station address keep 0. This parameter you can see here automatically adding, because so a base parameter for communication setting for a Mitsubishi PLC, these parameters. Okay, just you can add here. I will go to COM2. Here so I have in COM2 how many, so I have here COM0, so one device and 1 to 9. This 9, so this 9 is VFD, but the first one, this module, this is a temperature module, so I have read 10 temperature sensor here with this module. So we will discuss one by one. So this 9, remember, this is a just VFDs. So here you can see this is my station address. So important thing is station address, so don't mix this one. Okay, I will go COM0. You can see here what I have. So first one, so wait one, okay, just wait. Yes, this is the name VFD. So from VFD1 you can see here to VFD9. I have 9 VFDs, so just the station address is here. All station address is here. Okay, I have temperature module. So in this temperature module, I can read more than 16 temperature sensors. So just I'm using 10 temperature sensor here. I will read by this one. This is my communication parameters. All communication parameters should be same to this my so set parameters. So communication type is Rs485, baud rate 9600, data bit is 8, parity known, and stop bit is 1. So why I use this parameter? Because my temperature sensor, so VFD is no problem, so they have more option for Rs485 parameter communications, but my temperature module just supporting this kind of the communication parameters. So this is not important, but all your device should be this communication supporting this parameter communications. Also, after I will add so weighing module, two weighing module. So here with parameter 20 and 21. So just this one now I don't add. This is my device. So here you can add easily. Just we go to COM0. First I will make communication parameter setting 8 1. So what if you need 7 events, what you need, so you can choose here, no problem. Just first I will go to Modbus. We need Modbus communication, yes. Also, if you need ASCII mode, so you need to choose this one. If you need RTU, so what is these two important things? Because if you learn about the Kinco HMI, so all version HMI, so they don't supporting this kind of the zero-based addressing. So from this one is address starting from, I think, from 1 starting, but from this RTU extend, so address starting from 0. So what you have in your device communication address, so you can just only use this and send to slave addresses. For example, if your VFD operation address is 200, so just you need here, so same to this. You don't need to something calculate for your address. Just make a communication, you and also here you need to add, and station address you can change, for example, like this. Okay, I will add another one. So Modbus and this station communication protocol does not support multiple PLCs. Why? I think this one is not supporting. Yes. Yeah. If I add here, just I need to go. Yes, zero base addressing I use here, but I don't have any errors here. But COM0. Sorry, here is for this one. RS232 just only one address. Yes, it's correct. For this one is not supporting. Yes, confirm on it. Now yes, we can add more. How many you need? So you can add more. Okay, we do finish, and you can see here automatically adding your device. So why I have two devices here? Just need to delete. Yes, this is our device. How many you need? So not how many, just how many supporting for RS485 you can add here. So this is just only for device adding to communication set. So just this one. We go to addresses, how we give address here. This is my frame 0. You can see here. This is my first. You can see here my first. This one is 11 VFD. So I need number VFD 4 and 13. So two number here. If we go, and this is a kind of address reading. So here you need to address with decimal address here, not 16. So decimal address here. I think so. This is was, yes, because now you can see here addresses like the here I'm using delta VFD for operation, and for frequency command this is I think 2000s 2000 and 2001. So I will just show you. I think hex was like this 2000. Yes, this number, remember. So if I go here, this is my delta VFD. You can see this address 2000. And if I give 2001, so you can see this is my frequency command here, 8193. So like this, you can read and write address by your communications slaves. Also, important thing is my macro here. I write macro for read one time all of these parameters, read and write. Okay, just one things. So I have temperature 1, temperature 2, temperature 3. Just for the variables, you need just do like this. So you need to choose your HMI. So my temperature module is station address is number 1 here. This is your station address. This is the number of device. And address is for first channel, so first temperature address is 0. Okay, for this one we add in communication system parameters, we add the RTO 0. So, and this is, you can see here address is 1, like this address is increasing, so go to 9. So this is my 10 temperature. Just here, so here just I will write this parameter to PLC register. So PLC register also I add here. You can see just I need PLC. My PLC is 0 address. So D register, D words I use here. Just only easily you can move temperature to PLC register. So about the VFD, which macro I've write here. My first VFD, this is another kind of VFD. So operation command and frequency command is a little bit different. Okay. Now you can see here I have two ifs here. If this is circulation just pump, circulation pump bit register. If circulation pump register is 1, so this is in PLC register. So I will write to my VFD register by communication number 18 for the start. And if I'll say I will write 1. So this is for run command, this is for stop command. And for the frequency, I will move just only this you can see here circulation pump F. Circulation pump F, this is PLC register. You can see here this is PLC register D51. I will write this to my VFD register. This is circulation per pump dash F dash output. I will write to my VFD. This is my VFD 1. Okay, so address is station address is 11. Okay. This is for frequency and this is for start and stop. Okay, this is my second VFD here. This is delta. All are now 8 kind of this VFD are using delta MS VFDL. For delta, for run command we need 18, and for stop command we need also one. Just a note here, sorry, one another VFD address, more address was another values. Yes, here this is one VFD for from me, so this is another kind of the VFD. For start command we need number 1, and for stop command we need number 5. That's enough. So this is okay. This was just only how to operate this macro, this my macro, how operating. So there is one kind of functions, good action, PLC control. Okay, so this is my PLC control. I it just only this LW99 1919. So this is a timer, actually timer at the timer address. So this automatically, by I think so, in half minute, half second, or in 1 second is cycling like this in HMI. So in any second, so I don't know, in half seconds this macro is operating. So how operating when the word register's value is changing. For example, if after 1 second I will read my temperature, so after 1 second I will, if I change my frequency is changing to my into my VFD. Also you can add like this timers here, you can add timer here. So sorry, this is daytime time, another timer we have. This is also important, just want to, yes, show you. So this is our timer after, for example, 1 second, or if you need half second, just you can do this macro. But okay, I will add here, but one thing is important here. If you add this timer into this frame, and this is in this Windows, if you in HMI, if you go to another Windows, for example this Windows, your timer is not working and your communication value is not changing. So this is very important. But that PLC control is always is controlling by the timer of the HMI. Okay, now we can go to tools and indirection online. Just, yeah, I see. So you need to compile. Okay, if I change something here, something else, I just want to go in direction online VHMI, and we see how, so how is communication working. And we go in direction online. So in direction online I will communicate direction with, directly to HMI. So I'm using network communication, and I will simulation here. Okay, just wait, looks now is reading. So my first frame, so this address I explained how. Now you can see here temperature is showing. Just I will take temperature sensor, you can see here. It's downward, you can see here now 32. So why is giving error? Because I'm communicating, I'm direction communicated with my just small is giving error. So I will go here. This is my animation. So you can see here. So I will run and stop all my VFDs and PLC register also here. Okay, I will run this one and give frequency, for example 15. Yes, I come back here. So this is 15, you can see. This 15 already is here writing to my first motor. Response is giving me. You can see here. So my PLC also is working good, no problem. This is also another VFD. I will run all my VFDs here. No, this is not VFD. And we can see in another frame our frequency. Okay, and also here. So we don't another one. Okay, I come back. Now you can see here. All addresses as now is running. So 2 is remember. Why is remember? I will come back. So another 2. Yes, this one. And this I need to give some video. And this one. Yes. Okay. Now you can see all my VFD is running. Also temperatures are reading here. This one you can remember. Now I will push to this sensor. Is increasing here. So this was about the Kinco HMI communication. Okay, so this is not too much difficult. Just need to try. But for me, also first time was very difficult. So to find some problems, you have some problem when you programming. So in any case, you have these problems.